Welcome to Flip Lesson 109 for the 6th grade. And today we are really kind of taking a continuation of what we looked at last time. Last time we talked about transformations, how transformations, when we move shapes around, it helps us to understand how things are congruent. Today we're going to take it to a more geometric level as we explore and describe how, well, what truly is a relationship between two congruent shapes. And as we look at that relationship between two congruent shapes, we're going to get another C word in here, which is why I'm saying congruent so small, is because we're going to also be talking about how there are corresponding parts. So let's take a look at this together. On the screen you have triangle ABC and triangle XYZ. And these are both congruent. All right. Now I could manipulate the shapes and tell you that they are congruent. But what we want to see here is how there are corresponding parts, right? Corresponding parts means that the measures of the sides, the measures of the angle are going to be the same. And we know they're going to be the same because they're congruent, because they are the same shape to begin with. So for example, right, if I told you that B was a 90-degree angle, right, angle B is 90 degrees, we would say that B corresponds, right? So which angle would it correspond to? Which one would it relate to? And we would look at Z and X and Y, and we would realize that, well, obviously, right, Y is the 90-degree angle. So angle B corresponds to angle Y. Right? We use that phrase. Right? Then another thing we would look at is, okay, so if those are the same, well, what are the other relationships? Right? So we would see that X, right, if X, right, this angle must be the same as this angle. Just like angle C, let me change colors just to make it a little clearer. Z, it corresponds with C, right? And that's because they are congruent. Right? I can also talk about the length of the side, right? If I measured YZ, that would mean that if it corresponds to this other triangle, that means BC, segment BC, is going to be the exact same length. And we could do the same thing with all the other sides, right? This side is going to be the same length as this side, and then, you know, this side is going to be the same size as this side because they are congruent. Let's put this into practice. Once we know that two triangles are congruent or have corresponding parts, we can start to understand them a little bit better. Now, when you look at two triangles, you might say, they don't look exactly the same. All right? And as you look at those two triangles, the fact is that your two triangles, your eyes can play tricks on them. That's what I'm trying to say. Your eyes can play tricks on these different things. But if I tell you that they're congruent, right? As you're looking at these two triangles, I tell you that they are congruent. Right? I've given you that information. They are congruent. If they are congruent, then we can use this idea of corresponding parts to help us understand it. And we can start to see relationships, right? So if this is the 90-degree angle and this is the 90-degree angle, if those are our two 90-degree angles, all right, let's start mentally rearranging, really transforming these shapes so we can see how these parts correspond. And so if this is the base of the triangle right here, and it's 7 inches, okay, what is the base of the triangle over here? Is it this side or is it this side? And if you look at it closely, right, and you picture it, right, you're going to understand that that's the same side. So now that we know that this side corresponds with this side, right, well, let's figure out which side, right? This side must correspond with this side. And suddenly, our unknown length of this side is discovered. We've discovered that this side must be 9 inches also because they're congruent, right? Back to that word, congruent. Which would also mean then that our third side must be congruent with this side. And so we have two triangles that are 9 inches by 7 inches by 11 inches. And we can do that because they are corresponding parts and they are, once again, congruent. Right? Ready to mix things up? When it comes to congruent, right, we can talk about length of sides. We could also talk about angles, as I talked about in this example here, right? Corresponding angles work with congruent triangles. But what about if they're just similar? You can see the four triangles on the screen. We start by just talking about, okay, what is similar, right? Similar, of course, means same shape but different size. Same shape but different size. So as we look at the three triangles on the screen, the first thing our eye is going to catch is that triangle 4 is not the exact same shape, right? These all have right angles, 1, 2, and 3. They all have those right angles, and this one clearly does not have a right angle. So it is not similar. But what we do see is 1, 2, and 3 are similar. 1 and 2, in fact, are actually congruent, but they are similar with 3. And so same shape, but different sizes. So what does that mean in terms of figuring out unknown ideas when it comes to similar triangles? When you have similar triangles, what you come away with is the fact that you get ratios or proportions. Right? Maybe proportions is the better word. Similar triangles are going to be proportionate to each other. Proportionate. Proportionate? Proportionate. That would make portion. All right. Spelling during math got me right there. Made me think a little bit. Proportionate. All right. They're proportional. They're proportions. So if we look at these two, we have triangle AXE, and it looks like I didn't label this one, right? So let's throw some letters in here. Let's call this one COW. So we got an axe and a cow. You wouldn't think that they go together, but they're similar. They're similar. As we look at this idea then, by understanding that they are proportional, we can figure out how things work. Now, because they are the same shape, right? Exact same shape, just different size. The first thing we can see is that the angles are actually not going to change, right? They're not going to change, right? Because they're the exact same shape, we would say that angle C, we wouldn't say it's proportional to angle A. We would actually continue with this idea of congruent. They are still congruent, right? Even though they're different sizes, right? So A is going to correspond with C, even in a similar triangle, and we would say that angle A is equal to 47 degrees. Just like angle E would correspond with W, so it'd be 43 degrees, and of course X is right angle. Right? And we can see those things. This is how we know, right? We see X, we see O, they're the same, right? We can see the relationships there. And so what we want to come away with is that angles are congruent. So in general, when it comes to whether it's congruent triangles or similar triangles, we can always say that the angles are congruent, right? Corresponding angles are congruent. They're the same. However, we can definitely tell that the sides are not the same in similar triangles. But this is where this term comes in. This is where we get our proportions, right? So that if I discovered the proportions of a triangle, I could tell you that let's just throw some numbers in here. Let's say this is 8, right? This is 4. This is 5, just for some numbers, right? They're proportional. Now, I'll just go like this to make it a little bit easier, right? They're my pen doesn't want to work right there. As we look at these numbers then, since they're proportionate, we can solve things, right? Since AE is proportional to CW, I could put 8 over 16, right? Right, proportionate, it's going to be equal to, let's say I want to figure out the length of, oops, not that one. We already know that length. The length of CO, right? So if I'm looking for this one, right? CO. I already know the length of AX, and we know that's proportional, right? These are the same, similar. They're similar, so they're proportionate. I am using the right word. There's the 5 there, and we would do some cross multiplication and come away with, right, 5 times 16, right, because that's not an easy relation. 5 times 16 is going to give us an 80, right, and 80 divided by 8 then is going to give us a 10, and maybe you saw that relationship already, right? 8 is double, 4 is double, 5 here would also be doubled then to get a proportionate triangle. It goes beyond triangles. We can use proportions in the same way when it comes to understanding other types of polygons, right? And it's you can see the relationship here, right? So we see 12 is the length, right? Which would mean this side is 12, which would mean this side is also 9, right? And so are they proportional? That would be the question in this one. Are they proportional? Are they similar? Are they actually the same shape? And so instead of just looking at the two images now and saying, are these actually similar, or do they really look the same, or is the differences between them now mathematically we can solve, right? I can say, okay, that's the length, right? Length over the length, is that proportional to the width over the width, right? So it's 3 times 12, right? That equals 36. Is that equal to 4 times 9, which also equals 36? And we would say yes, which means that ABDC, I got to read them in the right order, right? Got to go in order. ABDC is proportionate to WYZX. You probably are looking at this lesson saying, I get it. Just give me the sample problem. Let me do it. All right, here it is. I'm going to stop talking. Here's your sample problem working with these, right? Take a minute. Make sure you take it all in, what it's all saying, and then go ahead and answer those questions. This is lesson 109.